Hi, welcome to Natilik Live with me, Ian Anderson, the Practice Director for Network and Data Center Technologies. I'm delighted to welcome Scott Hodgdon from Cisco Systems. Scott is a Senior Technical Marketing Engineer, has been with Cisco for 18 years and has been working on the Catalyst switch range for a number of those years. So Scott, we're here to talk about SDA, Software Defined Access. Can you tell me a bit about the components that make up Software Defined Access?
Sure. There's three main components that make up SDA. You've got the Identity Services Engine. This is responsible primarily for policy. So one of the advantages and benefits of SDA is to do segmentation and micro-segmentation. So traditionally within a network, we've been able to do segmentation, let's say with a VLAN or maybe with an MPLS VPN and things of this nature. With SDA, I can do that. I can do it down to the port level dynamically, which we couldn't do before. But then in addition to that, inside of that level of segmentation, which I sometimes call network level segmentation, I can do micro segmentation. So I can now create groups using ICE. And this is part of our TrustSec technology that we've been deploying now for, I think, close to the last 10 years. So each one of these groups can have a policy between it. So instead of taking a whole bunch of groups and creating a whole bunch of individual segments, which is a lot more complex to manage and a lot more complex to roll out and troubleshoot, I can create a limited number of segments, but then create policies between those groups within those segments using ICE. So ICE becomes kind of the policy orchestrator, if you will, of an SD access environment. Then you've got DNA Center. DNA Center is the orchestration platform that allows me to discover my devices, to build the SD access environment, and to make changes to that. And the advantage here is because I would normally have a large footprint of, let's say, edge devices and core devices and distribution devices, and traditionally I would have to go to each one, or I'd have to create my own scripts where, of course, human error comes into play, and you push out a script to 50 devices that's wrong, now you got 50 things that are broken. With DNA Center, all of the stuff that we push out is based on our best practice recommendations. It's all tested in our labs beforehand, and it's all done by our principal engineering team. So for us to roll out, manage, and make changes using an orchestration platform like DNA Center makes the environment just that much more stable. And then, of course, you've got the Cat9Ks. The Cat9Ks are the basis of most of the networks that have deployed SD access today, although customers that have, let's say, Cat 3650s or 3850s, which were based on the first generation of hardware that evolved to become the Cat9Ks, that hardware is also programmable enough that I can take these new header formats, such as VXLAN and these things, and I can just program those 36 and 3850s to take advantage of this new solution. So we built the 36 and 3850s with that forward-looking programmability in mind. But the Cat9Ks, I would say, in my experience of doing probably close to 20 to 25 networks here in terms of design and deployment in the UK, have been the backbone of the vast majority. I'd say probably 23 or even 24 of those networks have been based on Cat9K.
Okay, thanks, Scott. And as an engineer from the past, I'm interested to know what are the underlying protocols that make up the fabric of a software-defined access solution.
Yeah, so the fabric is essentially a two-part construct. One of what we call the underlay is what we call a routed access infrastructure. So traditionally, customers would primarily have layer 2 to the access, where they'd have a VLAN, let's say, that would be stretched up to a distribution or a collapsed core distribution where I would have my layer 3 interface. Some customers, maybe 10 to 15%, would have that layer 3 interface on the access layer itself. And that's what we would call a routed access, because I don't have any layer 2 after the access layer. For SD access, the underlay has to be a total routed access infrastructure. We'll get into some of the benefits of that in a minute, but primarily what we recommend for that is ISIS, the intermediate system to intermediate system routing protocol, which you've primarily seen run in service providers because it's very scalable, it's very fast to reconverge, and it's very flexible. For example, we have a few customers here in the UK, education customers that are running dual stack v4, v6 right now, for example. They run ISIS as a routed access infrastructure because ISIS doesn't have a v4 and a v6 version. I can just run ISIS, I run v4 now. For that day, eventually when v6 does come and becomes more predominant throughout networks, I just don't have to do anything. I don't have to install a separate routing process for that. So although we recommend ISIS, you can use OSPF, you can use EIGRP, whatever routing protocol you want. But ISIS is what we build our Cisco validated designs on, our Cisco validated deployment guides, and it's what we solution test. But the others are supported. So ISIS or any routing protocol is a routed access for the what we call transport or the underlay. On top of that, you then have an overlay. The overlay consists of two things. It consists of LISP, the locator ID separation protocol, which has also been primarily seen in service provider environments. It is about 10 years old or so at this point. It was built primarily to connect V6 islands across a V4 backbone to other V6 islands. And what it does is it basically abstracts whatever address you originally have and allows you to add a header on that so I can route it across whatever intermediate infrastructure there is. Well, in this case, the header we use is VXLAN. VXLAN is seen in other places like Cisco's ACI environment, for example. And VXLAN in the SD access environment is just a header. So I have IP information in there to go from one point in the fabric, let's say the edge that faces the users, to maybe another edge if I'm talking point to point, or if I'm going out of the fabric through what we call the border. I will have IP addresses in there. And then I'll also use SGTs, or the scalable group tags. Now, SGTs are part of Cisco's TrustSec solution. And SGTs are what allow us, we were talking previously about this micro-segmentation concept, SGTs are what allow us to do that micro-segmentation. So instead of assigning everything policy based on IP, you'll be in a group, I'll be in a group, you can have devices in a group, and I can create those policies. Now going back to DNA Center, within DNA Center, it pushes those policies to ICE, ICE pushes that to the network, and then as devices come into the fabric, their traffic will get their VXLAN header plus the SGT gets added in the VXLAN header, which makes it easier to transport across any intermediate devices to wherever the enforcement points are. So primarily when you look at SD access, you're talking about routing protocol, preferably ISIS, SGTs for policy, and then VXLAN and LISP for the overlay kind of routing, if you want to call it that.
So in terms of if I'm an organization and I want to move from a traditional network infrastructure to a software-defined one, what are the key considerations that they need to take into?
Yeah, so this is a very common question that comes up in design sessions I have with customers because it really is a mind shift from the traditional. You know, as I said previously, most customers will take a layer 2 VLAN and they'll stretch it if they need a subnet to exist across an infrastructure. And then of course you're adding spanning tree and that in there. Even when I was a customer 20 years ago, this is how we did things. And it's still how most customers do things because it's easy. I just stretch a VLAN, but then you have to deal with other things. So you kind of have to change your mindset. Look at your applications. Most applications today talk layer 3. They don't really talk layer 2 at a VLAN level. They talk layer 3. And so a VLAN just becomes a way to stretch a subnet, a layer 3 construct. But I don't have another way to do it unless I do SD access, right? My traditional way is a VLAN. So it takes a little bit of a mindset change. It takes a little bit of a change as well in terms of policy, for example, because again, I'm getting away from IP-based policy into group-based policy with the micro-segmentation through ICE and through DNA Center building those policies. It takes a little bit of a design change because now I start to have to think about the devices that are attached to the network, how they talk to each other, where I want them to talk. But you know, it's not that difficult. I mean, it's a little scary for a lot of people. You know, when you've been doing something the same way for 15 or 20 years, you just kind of tend to want to do it that way. But you're also limiting yourself in terms of security, in terms of device mobility, both wired and wireless, in terms of this kind of flexibility that you get with the fabric. So customers really just have to start to think, you know, what am I really delivering for services? What do I really need? What are my major concerns for services? And that's tending more and more towards security these days. And, you know, let's face it, a traditional layer 2 VLAN rolls up to a common routing table, and that can be attacked and affect all the VLANs that roll up there. Segmentation delivered by SD access through DNA Center, through micro-segmentation gives you a lot more security. So most customers are saying, okay, yeah, let's start thinking about how I'm going to deliver those services and start looking at how I can maintain my user experience while delivering that extra security.
Excellent. Thank you. Thanks very much for your time today, Scott.
Absolutely.
So thank you everyone for listening. If you want any more information, reach out to natilik.com or to your account manager for an existing client, and we'll be delighted to help you. Thank you.
Thank you.